Hello, in this video we will see some examples of inference rule, and we also will see proofs using propositional logic. So what inference rule is illustrated by the argument given. It says if Martha is the author, then the book is fiction, but the book is a non-fiction, therefore Martha is not the author. So if we let this statement Martha is the author as A, then the book is not fiction, make it the statement book is not fiction as F, but is also can be written as and. Book is non-fiction, that means not F. What conclusion can we make? So as we see, R implies S is true, A implies F is true, and not R, F is true, or I would say not S is true. So what can we conclude? We can conclude that Martha is not the author. We can conclude not A, the same as here. So this conclusion it's made because of MT, or modus tollens. The next example, if you have a current password, then you can log on to the network. You have a current password, then you can log on to the network. So let's make it statement. For example, current password, let's call it P. It says if you have current password, then you log in into the network, maybe log in for, we'll call it L. This period here is like an end. And you have a current password, then and P. So my conclusion, this is the same as R implies S and R. So we can derive S, which means we can derive login into the network. We can derive L. And what we used here is modus ponens, MP. The next example here, the dog has a shiny coat and loves to bark. Consequently, the dog loves to bark. So the dog has a shiny coat, let's call it C, and the dog loves to bark, let's call it B. And therefore, the dog loves to bark, B. So here is where we have R and S. This can derive either R is true or S is true. And in our case, was the dog loves to bark. So what we use simplification, or sim. Let's see this example. It says decide what conclusion, if any, can be reached from the given hypothesis and justify your answer. So the first example we have, if the car was involved in a hit and run, so let's call this as a C, then the paint would be chipped. So P as the paint would be chipped. But the paint is not chipped, but not P. So this is similar as stating R implies S and not S. So my conclusion, what can we derive, is not R, when in our case R is a C. So we conclude not C, which means we can conclude that the car was not involved in a hit and run. So the rules that we used is MT, or modus tollens. In the next example, if the bill was sent today, then you will be paid tomorrow. So let's call it B for the bill. The bill was sent today, then you will be paid. Paid is P, for example, and you will be paid, NP. So the conclusion obviously can be made is that B is true. That means indeed the bill was sent today. And this is based on MP. So the next example, it says, the grass needs mowing and the tree needs trimming. Maybe we call this G and T. And the grass needs mowing, and if the grass needs mowing, then we need to rake the leaves. Let's call it L. So what conclusion can we make here? So the conclusion is, I would see it is L, because G is true and T is true. That means G is true, and if G is true and G implies L is true, therefore conclusion can be L because of MP. So the conclusion we can make is we need to rake the leaves. Let's see this example. Justify each step in the proof sequence. So we need to prove this, and the steps are given. We just need to justify what are we using. But before we get into this, in the previous video, we showed the deduction method. We proved deduction method. And the deduction method states that A implies B implies C, and we prove it in previous video. This is equivalent to stating A and B implies C. What does it mean? It means that your implication here can be changed to an addition, and that is a deduction method. So let's see this proof. So to prove any argument like this one using the proof sequence, so first, as we said, we're going to assume these are all hypotheses. So here, this and this, I'm going to change it to an and based on deduction method. Based on deduction method. And then, so if you remember P1 and P2 and all the way to Pn, this we assume are all hypotheses, and from this statement P, we need to conclude Q. And if we can conclude Q, that means the whole argument is true. That's what we said in the previous example. So what we're going to be stating is that we're going to assume A is true because it's a hypothesis. B implies C is true, and B is true, it's a hypothesis, but deduction method. Okay? And now, based on this, 1, 2, 3, all of these are given, are true. How can we conclude C? So if you look carefully, we know that B implies C is true, and B is true, and therefore C must be true. So what I just said, what I just derived, is C is true based on what? It is MP. And this is how we write it. Based on statement 2 and 3, and using MP, we could conclude that C is indeed true. So here, what we always have to keep in mind is that these are all hypotheses, okay? But what we need to get into, this is your P1, P2, and P3, assume are true. You're going to use proof sequence to reach, this is your goal. We're going to reach that A and C is true. Okay, now it's very simple. From 1, we know by hypothesis A is true, and here in 4, we just proved that C is true from 2 and 3 MP. So A and C must be true, and that's because of connections. So connections. So if R is true, S is true, then R and S is true. So what we say, we must state where is this connection coming from. From 1 and 4. Therefore, we're done. This is the goal. So this is how we do this proof sequence. We state you have to state your hypothesis, use the proof sequence, use these rules, and to get into your Q or the goal or the last statement. Let's see this example. It still says justify each step in the proof sequence. So again, This is one hypothesis. Every time you have an and, there is a hypothesis. Another and is a hypothesis. Again, this is P1, P2, P3. You have to imply Q. That's what we stated before. This is our goal. This is what we need to get into. So A implies B or C is by hypothesis is true. Not B is true. It's a hypothesis. Not C is true is also hypothesis. And now, how can we get into 4? Not B and C is true. So you take a moment and you look at this and you're going to say that again, it's conjunction. So since each one of them is true, the addition and must be true. So I would say 2, 3 conjunctions. And if you look at this, always keep in mind, where is my goal? My goal is not A. So where is not A? I could reach it here from 1, but I have B implies C. So B or C. So how can we get from here to B or C? This is for De Morgan. If you look on the side, this is De Morgan, right? This is an equivalent relationship, so De Morgan. So that's what we have. These are equivalent. And so A, this is not, A implies maybe R and not R. That means not A. What did we just use? R implies S, but not S. This is not R. This is empty. So we could say that between 1 and 5, empty, we could get to not A is true, and that's our goal. Now the whole statement is proved to be correct.